Question 786. For the parametric equation x is equal to 2t squared plus 3 and y is equal to 4t cubed minus 2t squared plus 1, which of the following is true? The answer choice A says the slope of tangent line to the curve at t is equal to -1 is positive. Okay, the slope of tangent line is the derivative of this curve, right? So the derivative of a parametric curve, dy dx, which can be written as dy over dt over dx over dt, right? That is equal to dy over dt is 12t squared minus 4t, dx over dt, that's 4t, right? If we simplify this, we can actually factor numerator the 4t, right? So 3t minus 1 over 4t. So 4t cancels out. So that is equal to 3t minus 1. So first the derivative at t is equal to -1 is equal to 3 times -1 minus 1, which is equal to -4. Negative, right? So this is not correct. This is not true. All right? Okay, the answer choice B. The graph of the curve has a vertical tangent line at t is equal to 0. The parametric curve has a vertical tangent line when dx over dt is equal to 0, but dy dt is not equal to 0, right? Okay, dx over dt was 4t, right? It was 4t right here. That is equal to 0 when t is equal to 0, right? But for the dy over dt, which is equal to 4t, 3t minus 1, that is also equal to 0 when t is equal to 0, right? So at t is equal to 0, both dx over dt and dy over dt are zeros, right? So we do not have a vertical tangent line at t is equal to 0. So this is not correct, right? Answer choice C. The graph of the curve is concave up at t is equal to 1. In order to find out the concavity of the curve, we have to find the second derivative of the equation, right? So here we have a first derivative. Our second derivative is equal to derivative of a first derivative with respect to x, but since our first derivative is in terms of t, we're going to differentiate this with respect to t, so over dt here, right? So that is equal to, here dy over dx, that's 3t minus 1. So the derivative of that is 3, and dx over dt was 4t, right? So our second derivative at t is equal to 1 is equal to 3 over 4 times 1, 3 over 4. Positive, right? So the graph of the curve is concave up at t is equal to 1. That is true, right? The answer choices is true. So the answer is C. Question 788. A particle moves along the curve 2x plus y squared minus xy cubed is equal to 4. If y is equal to 1 and dy over dt is equal to -2, what is the value of dx over dt? Alright, since we are looking for dy over dt, we're going to have to differentiate this equation with respect to t, right? So that is equal to 2 times derivative of x with respect to t, that's dx over dt, plus derivative of y squared power rho times derivative of y with respect to t, dy over dt, minus, here we have x times y cubed, right? So we're going to have to apply the product rule. So derivative of x, that's dx over dt y cubed plus x times derivative of y cubed 3y squared power rule, then chain rule, derivative of y with respect to t, right? That is equal to derivative of 4, that's 0. So far so good. Here, when y is equal to 1, what is the value of x? Let's just substitute 1 for y. Then we have 2x plus 1 minus x times 1 cubed, that's x, is equal to 4. So x is equal to 3, right? When y is equal to 1, our x is equal to 3. So far so good. So let's substitute 1 for y, 1 for y, 3 for x. Okay, and it is given that dy over dt is negative 2, right? So this value right here is negative 2. Negative 2. Here y is 1, right? Now if we simplify this equation, 2 times dx over dt plus 2 times 1 times negative 2, that's actually negative 4, right? So minus 4 minus dx over dt times 1 cubed, that's just the dx over dt plus 3 times 1 times negative 2, right? So 3 times 3, 9. 9 times negative 2, that's a negative 18. So that's negative 18 is equal to 0, right? So 2 times dx over dt minus 4 minus dx over dt plus 18 is equal to 0. So if we simplify this, dx over dt, here we have 2 dx over dt minus 1 dx over dt. 2 minus 1, that's 1, right? Here we have minus 4 plus 18, that's plus 14. So dx over dt is equal to negative 14, right? That's our answer. Question 802. Find the area under the curve described by the parametric equations x is equal to 2t plus 1 and y is equal to 4t squared minus 2t for t is from 1 to 2. Okay, in order to find the area under the curve, we have to find the equation y in terms of x, right? So here we have x is equal to 2t plus 1, then 2t is equal to x minus 1, t is equal to x minus 1 over 2. So substitute this expression for t right here. So we have y is equal to 4 times x minus 1 over 2 squared minus 2 times x minus 1 over 2. So if we simplify this, that's going to be x minus 1 squared minus x minus 1, right? If we factor this, we have x minus 1 squared x minus 1 here, right? So we're going to factor x minus 1. Then what we have here is x minus 1 minus 1, right? Minus 1. So our y is equal to x minus 1 times x minus 2. So far so good. Here we have xy plane. This function right here has x-intercept at x equal 1 and x equal 2, right? It is a quadratic function, so the graph looks like that, right? Okay, when t is equal to 1, our x is 3. When t is equal to 2, our x is equal to 2 times 2 plus 1, that's 5, right? So we are looking for the area under the curve from x is equal to, let's say here's a 3, here is a 5, right? So if we have this parabola, then we are looking for this area, right? So the area under the curve from x is equal to 3 to x is equal to 5, that's going to be definite integral from 3 to 5 f of x, which is x minus 1 times x minus 2 dx. That's our area, right? Okay, so if we solve this definite integral, that's x squared plus, it's minus 3x plus 2, right? dx. So that's going to be x cubed over 3 minus 3x squared over 2 plus 2x from 3 to 5. So that's going to be equal to, if we substitute 5, that's 125 over 3 minus, substitute 5, 3 times 25, that's going to be 75, right? So 75 over 2 plus 2 times 5, 10, minus, if we substitute 3, 27 over 3, that's 9. That's 27 over 2, 2 times 3 is 6, right? And if we use our calculator, that's going to be equal to 38 over 3. So this is our answer.